Hi, welcome back, IntroStat student. Today we will be continuing with some of the exercises in Unit 10 on sampling distribution. I believe we have finished what is a sampling distribution lesson, and we finished the sampling distribution of a sample proportion. All right. So the last video that I did, it was finding probabilities with sample proportion, and that one was made possible by the fact that um, we actually had to use the condition of showing that the sampling distribution is approximately normal, right? The n times p greater equals to 10, n times 1 minus p greater equals to 10, and then we have to find the mean, which is the unbiased estimator. So the mean of the sampling distribution of the sample proportion is actually the population proportion, and the standard deviation. The formula for that is square root of p times 1 minus p divided by n. So hope that you review that, and then we just use the normal CDF to solve the probabilities that way. So today we will continue with sampling distribution of a sample mean. Okay, sampling distribution of a sample mean. So it's about the same idea, but in this for this lesson we are dealing with mean. Mean is not proportion. Mean is things that are quantitative data, right? Quantitative data, things that we can add, subtract, and find average, things that have a meaning when we do all that. So those are the videos, and I'm going to dive straight into the mean and standard deviation of sample means. All right, so grab my pen. So let's dive in. So Karina plays a video game that is scored by round. In about 500 rounds, as you can see, that's your N. 500 rounds, her average, a career average, is 20 points per round with a standard deviation of 5 points per round. All right, suppose we take a random sample of 3 rounds. So, so you can see that in about 500 rounds, career average is 20. So do you see that that is your big N? Your population size is 500, and the career average, right? The population average is 20 points per round, with a standard deviation of 5 points per round. Suppose we take a random samples of 3 past rounds. That's your small n, and small n equals to 3. Okay, that's your small n. So this is your big N, right? Your population size, and that's your mean, right? That's your mean, mu. Okay, and 5, right here. This is your standard deviation, your population standard deviation. This is your population average, and that's your population size. And this 3 is the small n, which is your sample size, right? Your random sample of 3 past round. Calculate the mean number of points, your x bar, right? X bar here, it means sample mean, right? X bar means sample mean. Okay, so you see that there's a bar behind on top of the x, so it's called sample mean, x bar. Right? Do not confuse with the p hat. P hat was p refers to proportion, and this was a sample proportion. Okay, so but we're not dealing with sample proportion, we're dealing with means at the moment. So calculate the mean and standard deviation of the sampling distribution of x bar. So here they're taking 3 rounds, right? Every 3 rounds, they take an average. Every 3 rounds, they take an average. But the 3 rounds is randomly selected, of course, from within the 500 rounds, right? So here, what is the mean of the sampling distribution of X bar? This mean is usually the same mean as your population average, as your population mean. So here, what's your population mean? Is 20. All right, it's 20 points per round. But what is your standard deviation of the sampling distribution? So the formula for that. So let me write out the mean first. The mean of the sampling distribution is the population mean. The standard deviation of the sampling distribution is, there's a symbol, right? There's a symbol which is this, the formula, sorry, is the population standard deviation divided by root n, right? Divided by root n. And you got to remember this. So in this case, what is your standard deviation from the population? It's 5. And what was the sample size? 3. So this is how it looks like, 5 divided by root 3. So the mean is 20. The standard deviation is 5 divided by root 3. And let's look at what our options are. Well, actually, there's no option. So here, we just put 20, right? Because that's our population mean. And here, so we need to use our calculator. So what was it? Was it 5, right? 5 divided by, okay, 5 divided by root. Now, square root sign is here. So second square root of 3, the sample size. So round to the nearest one decimal place, 2.9, because this is 2.88. So we need to look at 8, the second decimal place, and that is above 5. Then we change 8 to 9. All right. Okay, so that's good job. All right, next one. So the birth weights of newborn babies in the United States follow a normal distribution. So they tell you that it's a normal distribution with a mean of 3.4 kilogram and a standard deviation of 0.6 kilogram. Researchers interested in studying how children gain weight decide to take a random sample of 100, right? This is your small n, sample size is 100 newborn babies, and calculate the sample mean weight, X bar. So this X bar is, so they randomly pick 100 newborn babies and find the average of that 100, right? And then they keep doing that. They throw, I mean, not that they throw the babies back, but they keep taking samples of 100, find the mean for that, another sample of 100, find the mean for that. And, is that a normal distribution, right? So they are trying to, we're supposed to find out the mean and the standard deviation of the sampling distribution of this X bar, right? Of this X bar. Now, I think I have tried to explain. So if your population is originally normal, right? It says that the birth weights of newborn babies in the United States follow a normal distribution. So your population is already normal. And so this is your population. Now your population is already normal. Now when you draw samples, right? You draw samples, right? After samples and your sample will also be normal, right? If you're drawing samples from a normal distribution, your samples would be normal. Okay, so if that's the case, what is this mean? Mean of X bar, right? Mean of the sampling distribution. And this mean is the same as this mean. So this mu is the mean for the population, right? Those two are equal, right? Because they're unbiased estimator. So whatever you pick a sample, your mean should be an unbiased estimator from your population, right? So this should be your mu. And here your mu is 3.4. Okay. So what is the standard deviation? Okay, what is the standard deviation? What is the standard deviation of this distribution, this normal distribution? And that follows this. So from the population, you have the standard deviation of the population divided by square root of n. And in this case, What is the standard deviation of the population? They tell you it's 0.6. Divided by, what is the sample size? 100. Now, we know that square root of 100 is 10. And if you divide anything by 10, you're moving the decimal one place to the left. So it's 0.06. So here is 0.06. So 3.4 and 0.06. I need to write that down. So 3.4. Right, second one is 0.06. Okay, so one more. We'll do one more. Right, a machine automatically dispenses a beverage of a desired size. When set to small, the machine dispenses varying amounts of liquid with a mean of 275 milliliters and a standard deviation of 10 milliliters. Suppose that we take a random sample of 5 of these drinks and calculate the mean amount of liquid X bar in each sample. Right? So we're not given, what's the population size. But can you imagine a machine dispenses a beverage, so it should be able to give us many, many drinks, right? So I would not be too concerned, right, about what is the population size here. Suppose we take a random samples of 5. So every time you take 5 drinks and then you find the mean. Another 5 drinks, you take the mean. And then you do a lot of samples and you create the thing called sampling distribution, right? The sampling distribution of X bar. So we can assume that individual drinks are independent. Calculate the mean and standard deviation of the sampling distribution. So in this question, we were not told whether the population is normal or not. That's okay, right? That's not a problem here. So what we need to do is the mean, okay? The mean of the sampling distribution should be the same as the population mean, right? This is called the mu because it's an unbiased estimator. And here it's 275, right? So we know that the mean should be 275. But what is the standard deviation of the sampling distribution? It's the same thing. We take the population standard deviation and divide it by root n. So population standard deviation is 10, right here, 10. So 10 divided by root 5 because the sample size is 5 and small n equals to 5. So 275, and we probably need to use that and calculate 10 divided by root 5. Okay, 10 divided by root 5, we need to find this. Okay, 10 divided by root 5. So 10 divided by root, so second, right, x, the symbol, square by 5. That is, we're supposed to round to 1 decimal place. So 1 decimal place is 4. You need to look at the next decimal place, 7, so it's 4.5. And then the mean is unbiased estimator 275, right? It follows the population. Okay, so if you have any question, please let me know. If not, good luck. Thank you.